Welcome to my short talk on our paper, The Isomorphism Problem for Plane Groups is in sigma 3p. As you can see from the title, the paper is about groups. And there's one fundamental question in group theory. If I give you two groups, you might want to know whether these two groups are actually the same group. And this is called the isomorphism problem. And like many problems in general, this is undecidable. So we cannot hope for an algorithm which solves this for all groups. But in our case, we restrict to the class of plane groups. So a plane group is a free product of a free group and some finite number of finite groups. Now there's one thing. Even if we only restrict to the class of plane groups, this problem still can have arbitrarily high complexity. So we also need to restrict how we give the inputs. And in our paper, we consider inputs given as inverse closed finite convergent length reducing rewriting system. So for short, ICFCLRRS. So for plane groups given in this form, we can show that the isomorphism triplet is in sigma 3p, so the third level of the polynomial time hierarchy. And just to compare, even for finite groups given as multiplication table, we don't know whether this problem is in p. We only know it's a quasi-polynomial time. And for the slightly more general class of virtually free group, there is some p-space algorithm, but only for input which is of even more special form than here. So we can illustrate a plane group by the Qiao graph. So here we have two groups, one generated by A, B, C with these relations, and generated by A and B with those relations. And here's the Qiao graph. And if you see, these look somehow like a tree, these Qiao graphs. In our paper, we use a geometric characterization of Qiao graphs of plane groups, which was proved by Adam and Murray, two of our co-authors last year. And we use this characterization to define this sigma 3p algorithm. For that, we just guess a generating set and an isomorphism, and then we verify universally whether this is indeed an isomorphism. And for that, we use some compression technique based on straight-line problems. So that's a sigma 2 algorithm actually, but then we also need to verify that this is actually a generating set, and that's the more difficult part. So I hope I could give you some idea of what we are doing, and hope to see you in the full talk at Stacks.